So we are going to look at our second day of end behavior. So remember, end behavior is what's happening at the end of the graph. So let's take this and we can plug this into Desmos here. So we have, let's see, 2x plus 3 on top. And on the bottom, x squared minus 4x minus 32. So we can kind of, if we zoom out, we can kind of see it looks like it levels off around 0. But again, how can we figure that out if we plug in values? So if I plugged in 100 and then 1,000, I can see that, yeah, it's getting closer and closer to 0. 10e4, move the decimal back 4 places. So what is really happening here? So let's see. If I plug in, we know that this is going to 0 on both of these. And let's see if we can just figure it out by looking at the equation. If I plug in a really big number for these x's, is that plus 3 really going to change it? For example, if I plugged in 1,000,000, right? We'd have 2 million plus 3. Or 2 million squared minus 4 times 2 million minus 32. Well, that's not really going to change, right? Those numbers aren't going to matter. So is the 4 times 1,000,000, where is it they're going to be a bigger number? 1,000,000 squared or 2 times 1,000,000. So this is kind of like saying we have a small number over a number that keeps getting bigger and bigger. Well, a small number divided by a huge number goes to 0. So for inputs of large magnitude here, the polynomial in the denominator is greater than, right, the polynomial in the numerator. So meaning we'll have a bigger number on top. Now, if we take a look at this end behavior here, so what happens on this one? Well, the 5, those won't really matter. This won't really matter. So we have where is our bigger number? Our bigger number is on top over a big number. Well, this gives us a huge number. So our end behavior on this one as g of x, the limit of g of x, as x goes to infinity. So as it gets bigger, our bigger number is going to be on top. It's going to go to infinity. And what about our limit of g of x as x goes to negative infinity? Well, let's think about it. This won't. So a really huge number cubed is a negative huge number divided by a big number, and it would be a big positive. So that would be a negative huge number. So it would go to negative infinity. Now what happens in this one as it gets bigger? Well, that plus 3 really doesn't matter. This is 2 times a huge number over that huge number. Well, the huge numbers would reduce out, and it's just 2. So the limit of h of t as t goes to infinity would be 2. And it would be the same thing if it's negative. It would, the negatives would cancel out and divide out, and it would be 2. So horizontal asymptotes. If the degree of the numerator is bigger, right? So we have to kind of look and we see, could it go to infinity or negative infinity, right? Because we have a big number, a bigger number divided by a big number. If the degree of the, oh, excuse me, I read this wrong. If the degree of the denominator is bigger, so that's like we have a big number over a bigger number, it's going to go to 0. If the degree of the numerator is bigger, then we have a bigger over a big number. So it's still going to be big, so that's going to be infinity or negative infinity. And if the degrees are the same, we have a big over a big. What we have to do is maybe if it's 2 big over 3 big, we look at leading coefficients. So if we take a look at this, the degree is bigger on the bottom. So the rest of this stuff doesn't matter. So it's like a big over a bigger. It's going to go to y equals 0. This one, the degree is on top. All right. So we have x squared over 4x. The horizontal asymptote, there is none. So I guess I could say up here that there is not a horizontal. And if they are the same, we look at those coefficients. So it's y equals 1 over 3. So here is it kind of written out. When the numerator is less than the denominator, n is less than m, so it's talking about our degrees right here. It's at y equals 0. N is greater, there's no horizontal asymptote, and when they're equal, it's those leading coefficients right out front. So let's see if we can figure this out. So we do have to multiply this out. So if I multiplied this out, I'd have 2x squared over x squared. So you'll notice our degrees are the same, so it's going to be at y equals 2. And it's asking for our limits. So the limit, and we can just say of f of x, as x goes to negative infinity is 2. And the limit of f of x as x goes to infinity is also 2. Now, when the bigger, oh, and this was just said as it goes to infinity. My bad. So we're just saying that it equals 2. The limit as it goes to negative infinity, okay? So negative infinity, let's think about this. 3 times a big negative cubed is a negative big number. And this would just become a big. So it's going to still be a big number, but a negative big number. So we would say it goes to negative infinity. So find the end behavior. Let's see, our bigger number is on top. So it's a bigger number over big. So again, we have to write this out. D of t as t goes to positive infinity. So as it gets big, it's a positive big over a big number. So that's going to be big. But then we have the limit of d of t as t goes to negative infinity. So this one would be positive, but 4 times a negative is negative, so that would go to negative infinity. The horizontal, okay, so horizontal, let's see, the top is less than the bottom, so the bottom gets a lot bigger, so our horizontal would be at y equals 0. And then this last one, as our limit as it goes to negative infinity. So this is a pretty big negative number. So it's a big negative. And it's bigger than this one would stay negative. So a bigger divided by a big, 2 negatives make a positive. So it's going to go to positive infinity.